Hello algebra students, this is going to be our last video for the year. In this video we're going to go over what about if we have quadratics set equal to 0. How can we find values of x that would make that equation true? So let's just think about this. There are already two factors, those binomial factors, x plus 9 and then x minus 8. So if let's say I said that x was 2, right? Let's pretend like x is 2 and let's just see if that works. So 2 plus 9, and then 2 minus 8, that's going to be 18 times negative 6, which definitely does not equal 0. So you want to think, what would make something 0? So if I know that if this whole thing turned 0, and then I multiplied it by the other binomial, it doesn't matter what would be in the pink binomial. If the yellow one was 0, it's going to turn both to 0. So looking at just the yellow, what would the value in there give so that I would get 0? Just negative 9, right? So if you had negative 9, and then you have negative 9, that would give you 0 times negative 17, which is true. So x could be negative 9, or you could try to make, well, let's see if we can make the second parenthesis 0 turn to 0. So that pink parenthesis, let's make this guy turn to 0. So what minus 8 is 0? 8, hopefully. And then if we plug in 8 for the other one, we just end up getting 17 times 0 equals 0, which is true. So the cool thing about these kind of questions is that there's actually usually going to be more than one 0, so more than one answer that would make the equation work. And we're going to do this we're going to factor, and then we'll look at ones that are a little more complicated on the factors to see which ones would work out. All right, so some other words that you might hear when you get this is called solving quadratics. We're going to take the y and make it 0. So we're basically going to take the whole quadratic and put an equal sign and plug 0 in at the end. Other words you might see for this are zeros, roots, solutions, x-intercepts. So with this one here, I'm actually going to do that one first. You could just think, all right, what number would have to x be in order to make that whole parenthesis turn to 0? That'd be negative 5, right? And then for this one, it'd be the same thing, negative 5. So in that case, there's actually only one answer, just negative 5. That's the only one that works. Now that's nice when they're really easy and there's no coefficient on the x. But when we look at these two factors here, it can be a little bit confusing to try to figure out, well, what times 3 plus 4 makes it equal to 0? So in that case, what we can do is we can actually set up a baby equation. We can actually go ahead and set the factor equal to 0. So that's typically what you'll see with these kinds of problems. Once we factor, then we set our factors equal to 0. And subtract 4 on both sides. It just turns into like a little two-step one. And there's our x value, where it equals 0. Then we would want to do the same thing for over here, although you might be able to look at that one and tell, well, what x would be. Or you could set the whole factor equal to 0. So sometimes you don't even have to set it, you can just look at it. Like this, because some of you could just look at it and say it's 4. Others of you might have to just go ahead and solve it. And the way that we write our answers, we put them in that set notation. We just write them in a set, so it just looks like this. It's not an ordered pair. It's just our two solutions for this. And again, what these answers are is what value, if I plug in 4 for x here and here, that whole equation would be true. It's going to equal 0. If I plug in, take this one off too. Oop. Try to get them at the end. There we go. If I plug in negative 4/3 here and here, it's also going to get 0 as our answer. So that's what these are. These are the two values when I plug them in for the x. it turns to a 0. Okay, so you can do a check in Desmos, and we'll do that in a minute. I just added that slide to remind myself to do it. So if they're not, if there's no factors, you could sit here and think, kind of rack through your brain, what are the numbers, a number that would work to get this statement true? Or we could just go ahead and factor. So I'm just going to factor, and I'll use the grouping method for this one. So we're looking for two terms that add to 2x but multiply to negative 15x squared. And I'm just going to bring down the equal sign of the 0 and the negative 15. So multiplying to 15, so negative 15 can be like 1 and negative 15, right? Negative 1 and positive 15, 3 and negative 5, negative 5 and 3. And so for this one, because we want it to add to a positive 2, it's going to be, look, those are the same answer. No wonder that didn't make sense. We'll get it. All right. You want to make sure that the signs are different, right? That's kind of important. So this would be a positive 5 and a negative 3. So that's the one that's going to work for this. When I multiply them, I get a negative. When I add them, I get a positive 2. So 5x and negative 3x. We're going to plug those in. Remember, the order doesn't matter. And then I'm going to go ahead and pull my factors out, maybe with a different color. There we go. So the GCF of those two terms is x, and I'm left with x plus 5. The GCF of these two terms is negative 3, and I'm left with x plus 5, and you want them to match. And then we go ahead and pull the greatest common factor out of each one of these, and we get x plus 5. And the green term has an x left, and the blue term has a minus 3. So once you get here, you can go ahead and say, well, what would x have to be in the first? It'd have to be a negative 5. And in the second, it would have to be a positive 3. So those are your two answers. And again, if you're not comfortable just kind of going with that direct route, we could also just set them equal to 0. So there's where the negative 5's coming from. And there's where the positive 3's coming from. So once you factor, you just set them equal to 0. Alrighty. What about if it's not equal to 0? It's equal to 3. So in this case, you have to have it set equal to 0 in order to factor. So we got to move that 3 to the other side. So you just subtract 3 on both sides. Then again, once you're here, we're just going to factor out that trinomial. And I'm going to use area model this time, just to switch it up. So 4x squared and negative 3. So I'm looking for two terms that add to negative 11x, but multiply to negative 12x squared. So it's like negative 12 and 1. I'm like over top of it, sorry. Are going to fit that criteria, so negative 12x and 1x. And then from there, I'm going to pull up the GCF, so that's x. That's negative 3. Fill in the sides, 4x and 1. So then when I write them out, x minus 3, 4x plus 1 equals 0. Oops. So at that point, you know, I could tell this first parenthesis the x is 0, but again, you could just go ahead and separate them. Set each factor equal to 0. And so then add 3 to both sides, so that's 3. And then minus 1 from both sides, and then divide everything by 4. So your two answers for this are 3 and negative 1. Ugh. I keep doing that, sorry. Your two answers for that are 3 and negative 1/4. So again, when you write these, usually we write them least to greatest, so negative 1/4, comma 3. And that'd be your answer for that one. Now, it's kind of nice because your Desmos will actually do a lot of this for you. You can check your answers in it. So I'm going to check in the first one. Let me see if I can change my screen. So Desmos will actually change the, there it is. It looks a little bit different, but that's okay. It will actually change the you can check your answer on there. If I can get it to work here. It's a little bit faulty. Okay, so I'm gonna like pull this over. And so when you go to check it on Desmos, the way you can do it is if I look at like this term here, this just means we're gonna think when we're graphing this that the y is gonna be actually replacing the 0. So I'm gonna type in y equals, then my quadratics, so x squared plus 2x minus 15. And a quadratic just makes this nice looking curve. And all you have to do, if y is equal to 0, that's just your x-intercept. So it's going to be this point and this point. So there's the -5 and 3. And I'm going to check the other one here. So if I go to this problem here, I want to substitute it the same way. I'm going to do y equals, and I'm going to look at that first step that I did where I had to move it to the other side. Y equals 4x squared minus 11x minus 3. And so this one's a little bit trickier because of that decimal, but -0.25, which is just a fourth, and then also 3 is also on there. So that's how you can find it too. You can just graph it and take a look at it, and it checks every time. Even the one that only has 1, I'm going to graph this one just to do it. So y equals, and sometimes it's already going to be factored for you like these couple here. And then x plus 5. And so you'll notice the reason that there's only one answer is because it just touches right there the x-axis and then goes back up. So that's why there's only one for that one. Alrighty, thank you for watching.